Okay. Ladies and gentlemen, welcome to the TMU MIT Hackathon on Health IoT. This is day one, and as you already know, that day one start with several keynote speech. And again, I want to also, on behalf of Taipei Medical University, I also want to welcome the MIT teams and the mentors from our local universities and hospitals, and all the participants for participating in this activity. 那我再用中文讲一下哈，就是欢迎大家来到我们第一届的这个健康物联网的黑客松。那这个黑客松呢是由台北医学大学跟麻省理工学院呢联合办理的。那么也欢迎大家到我们这个地方哈，这个叫做台北医学大学的大安校区哈。那这个是今天才开放使用，所以我们是第一群使用这个大安校区的人们哈。那北医大呢，大家知道台北医学大学在吴兴街里面，那但是因为空间不足，所以我们也把这个整个大楼租下来哈，就把它称作大安校区。那么大家我也很感谢学校很多单位，包括总务处了，包括这个这个管理处都很配合，帮我们把这个场地很快的整理起来。所以我们这3天呢，得以在这边呢，几乎是一个全新的场地呢，来办理这个活动啊。那我也特别感谢呢，MIT 有5位的这个学者呢，特别从波士顿呢飞到台湾来帮我们这个做这个协助这个活动哈。那我相信各位参赛者应该心里都有一些 idea 哈，想要在这边好好的发挥。那也想接受呢我们这个我们台湾自己还有我们 MIT 的这个教授呢学者的一些指导哈。那我相信接下去的2天半的这个时间里面呢，各位一定会得到非常充分的学习跟非常充分的脑力激荡的机会。好，那你投入越多呢，我相信你的回报一定也就越大。那这个 Hackathon 活动呢，晚上我们是有准备让大家打地铺的，所以到了晚上呢，这块区域就会把它整理成适合打地铺的地方哈。那我们21楼也有洗澡的地方，如果你觉得你得要洗澡的话，21楼我们有准备冷热水也都有了哈。本来这个办公大楼是没有热水了哈，我们特别把它锅炉把它修好，让这个冷热水都有。所以如果晚上需要在这边打个地铺那或者是要洗澡的，也都是我们都已经准备好了哈。那也非常感谢我们工作人员呢不眠不休的去花了很多时间准备哈。但是也特别再次跟大家抱歉，因为台风的关系，我们把本来4天的活动缩成3天哈，因为连续放两天假，我们很多事情就是我们想要准备，可是也没有人可以帮我们忙哈，很多 delivery 啦，很多这个东西都没有办法送过来哈。不过不管怎么样，总是大家都到了现场。那接下去呢，我们就有这个2天半的时间呢，可以好好的把我们的这个脑力呢，好好的这个发挥一下哈，在这2天呢，好好发挥一下，希望能创造一个不一样的一个未来。So I will also ask the leader of the MIT team, Dr. Celi, to say a few words.
Thanks, Jack. Thanks for having me. I actually first came to TMU in 2011 and gave a presentation here. And even at that time, I said that I wanted to come back, and I actually brought a whole crew with me this time around. And I wanted them to stand up and say a few words. There are some colleagues who flew from Boston and Washington, D.C. There will be 2 more people who are joining us also from Boston tomorrow. And there are some colleagues from Thailand. And I'm going to pass on the microphone to some of them to introduce themselves right now.
Hello, everyone. Thank you for having us. Looking forward to this. I'm sure it's going to be a lot of fun for everyone. My name is Eric Winkler. I work with Leo and the rest of the Sana team on the Sana mobile platform. I am the lead developer, and I will be looking forward to what all of you come up with.
Hi, my name is Kenneth Peck, and I look forward to seeing what you guys do over these next few days.
Hello, my name is Alan Degan. I work with the Sana team as well, and I'm looking forward to working with you all in the next few days.
Hi, so my name is Wei Hong, and I'm also work with Leo and Alon and Ken and Eric also. And I'm actually a student, a research fellow in Harvard Med School and Massachusetts General Hospital. Thanks.
And I'm gonna go all the way to the back and welcome some guests from Thailand. Sorry. There you go.
My name is Pipat. I'm from Khon Kaen University, and I'm looking forward to see all the project, what's going on here. Okay, thank you.
Hello, I'm Bandit. Nice to be here. Thank you.
Hi, I'm Patharavit Ponpinit. I'm from the Faculty of Computer Engineering from Khon Kaen University. Thank you.
So last year we actually went to 4 countries doing a similar event, and the main objective that we have for this event is really bringing together people with various backgrounds. And I'm going to show a slide later during my talk. And as Jack alluded to, it's not as easy as it sounds. But last year we were in Uganda, Greece, Colombia, and Mexico. The next year we will be in, we started off here in Taipei, going to Thailand, Nepal, as well as Singapore. We also have these events called Datathons, and Datathons are a bit different from Hackathon because the focus is not on products. The focus is not on software or hardware. The focus is getting information from databases. And I think some of the teams today have that as well as their main objective. So again, as my teammates have said, we look forward to this event. I'm pretty sure this will be very different from the previous events that we've been to, and we are hoping that you take advantage of us while we're here. Thanks.
Thank you. 那今天呢，开幕我们还有几位贵宾，等一下我们也会一一介绍我们的 mentor 哈。那 mentor 我在这边就先不介绍。那另外呢，还有我们的 sponsor 是萧中正医院的傅仲荣副院长啊。好，谢谢。那到闭幕式的时候，柯文哲市长也会来参加颁奖典礼哈。所以如果大家努力一点，可能就是那就是可以表现一下哈。好 ，OK。So now I'm going to introduce to you 2 speakers that's in this afternoon, are 2 of our keynote speakers. The first speaker is Leo Anthony Celi that you just met. He has practiced medicine in 3 continents, and so that gives him broad perspective in healthcare delivery. His research is on secondary analysis of electronic health record and global health informatics. He founded and co-directs the SANA at the Computer Science and Artificial Intelligence Lab at the Massachusetts Institute of Technology. He also holds a faculty position at Harvard Medical School as an intensivist at the Beth Israel Deaconess Medical Center, and is a clinical research director for the Laboratory of Computational Physiology at MIT. And he also is the course director of 2 MIT courses, HST 936 and HST 956, respectively. I think he will talk a little bit about the courses as well. Would you? Oh, no? Okay. But you will be able to find one of the course, HST 936, online in EDX, in edX platform, very soon. If you have any question, you can also ask him. The second speaker is Dr. Terry Guo. 大家知道郭台铭也是 Terry 郭了哈，不过我们这个比郭台铭更帅得多哈。That Professor Dr. Terry Guo is the professor in the Institute of Brain Science, National Yang-Ming University. His research institute ranges from medical engineering, cardiovascular physiology, and neurophysiology to sleep medicine. Professor Guo also developed original techniques related brain science research, including both hardware and software. He has published more than 100 research articles and patented more than 50 of his invention. 他的专利真的非常的多哈，可能是我看过最多的。那 Professor was the recipient of numerous awards in academic and research, including the 2004 10 Outstanding Young Individual in Taiwan， 就2004年的10大杰出青年哈。He is also a key medical educator promoting clinician scientist training in Taiwan. So, without further delay, let me give you Dr. Leo Anthony Celi.
And just here, there's no clicker. Okay. I had to change my talk last minute because yesterday I gave a talk about addressing the problems of healthcare, and I really don't want to give the same talk. So this is slightly different, but I think you're going to be enjoying this talk as well. But this is really trying to address all the hype around big data and precision medicine. You've heard those phrases over and over again to a point that you're already frustrated when you hear big data and precision medicine. And I myself am frustrated about the use of the phrase big data and precision medicine. And it's because a lot of groups out there, people out there are promising things that we cannot deliver. So what I wanted to do over the next 20 minutes is deconstruct the hype around big data and precision medicine. Silicon Valley disruptionist is a term used to describe the language with which startup companies would use to hype up some of their ideas. And it's filled with grandiose promises, primarily to lure investors as well as early users. And it's rooted in the preoccupation with unicorns. I'm pretty sure some of you have heard the word unicorn. A unicorn is given to a startup company with a valuation exceeding $1 billion. And typically, the subject looms large in the public consciousness with little going on behind the facade. Thanks. And, okay, and I sort of alluded to this yesterday. Precision medicine is nothing but a rebranding of personalized medicine. And personalized medicine was born in 1999. So Francis Collins, who is now the director of the National Institute of Health, he at that time was the director of the Human Genome Project. And in 1999, he made these 6 bold promises. He said that common diseases will be explained largely by a few DNA variants. This knowledge will lead to improved diagnosis and will drive preventive medicine. Pharmacogenomics will improve therapeutic decision-making. Gene therapy will treat multiple diseases, and that there will be a substantial increase in the novel targets for drug development and therapy. So none of these promises really have been delivered since their pronouncement in 1999. And now our idea is that this precision medicine, medical care and public health will be radically transformed by prevention and treatment programs more closely targeted to the individual patient. And they say, well, how are we going to do precision medicine? They say that we will achieve this by sequencing more human genomes, by creating bigger biobanks, and by linking biological information to health data that is stored in electronic health records or obtained by monitoring technologies. Because of the interest in personalized medicine and precision medicine, we've seen tons and tons of research being funneled towards this particular area. So between 1974 and 2014, looking at all publications in PubMed, we found a 410% rise in the number of publications. So that's well and good. But when you look at publications primarily looking at genomics, there has been a rise, a disproportionate rise of more than 2,000%. And this year alone, $15 billion of the $26 billion that is being invested by the National Institute of Health in terms of extramural funding is invested in genomics and precision medicine. So I'm going to talk about 3 hypes that we have around genomics and precision medicine. And the first hype is that the human genome will transform disease risk prediction. What we found so far is that the relative risk for the vast majority of gene variants rarely exceeds 1.5. So what does that mean? It means that for the DNA mutations that we have discovered that are linked to certain diseases, having those DNA mutations really increases your risk of having that disease by only 50%. So 1.5 risk ratio in terms of having that disease. So it's not a marked increase in terms of your risk of having that disease. And if you add them to what we already know about those diseases and what are the risk factors, they actually add very little useful predictive power if you compare them to traditional risk prediction algorithms for those diseases. And most importantly, improved adherence with lifestyle interventions expected to result from the provision of genomic risk information has not been demonstrated. So just letting you know that you have a very high risk of heart disease 10 years from now, typically it's not enough to convince people to stop smoking, typically not enough to convince people to start exercising or to eat more healthily. So the expectations that a few DNA variants explain most common diseases have really faded as the genetic architecture of most diseases has proved to be formidably complex. So it's not that easy to, for example, if we think that we could discover what's the main mutation behind diabetes, we don't expect for the outcomes from diabetes to be radically transformed as a result of that, discovery. So it turns out that hundreds or even tens of thousands of genetic variants are involved in each common disease. The second hype that I wanted to dispel is the hype that gene-based drug targeting will radically improve outcomes. The disease that obviously that have attracted a lot of attention is cancer. But so far what we have found is that gene-based therapy for cancer has very limited impact in terms of survival. And maybe because this is because of the fact that cancer has a very adaptive nature. So even just attacking one mutation, the cancer is usually able to evade that blockage of that mutation and would continue to spread. And although finding a subgroup of the population that is at very high risk of cancer is important, no new therapy has resulted from discovery of the mutations. A good example is the BRCA gene. So the BRCA gene was actually discovered 25 years ago now. We know that this is present in about 5% of patients with breast or ovarian cancer, and that those with the BRCA gene are at very high risk of developing these cancers. And everyone has heard of Angelina Jolie undergoing preemptive double mastectomy because she has this gene. And since the discovery of the BRCA gene, there has been significant improvement in the death rate from breast cancer, but none of that is a result of the discovery of the BRCA gene. I gave this example yesterday, the sickle cell trait. So the mutation that would lead to a defective hemoglobin was discovered almost 60 years ago now. And my question is, how many targeted therapy has emerged for sickle cell anemia where we know exactly what mutation gives rise to this disease? And the answer is 0. So we have not found a single gene-based therapy for the treatment of sickle cell disease. And that tells you that this is not an easy field. Like it's not, and I really feel bad when people say that when we discover the gene causing this, we're gonna be radically treating this, this particular condition, because it's not as simple as that. And a great example is sickle cell anemia. So there are the biological processes that are set in motion by a single amino acid substitution leading to the complications that we see turn out to be very complex. They're not predictable from the genomic defect. And we need to understand the complexity of biological systems at the level of tissues and organs before we could have a better understanding of the disease. And that's not just true for sickle cell disease, but all types of cancer as well as all types of chronic conditions. There was a study that was published last year, and it was a randomized trial of targeted therapy based on molecular profiling for advanced cancers. And the cancers are from all sorts of origin. And what the trial showed was that there was no improvement in progression-free survival between those people who received and did not receive gene-based therapy. There's an ongoing trial that is sponsored by the National Cancer Institute, and what they want to do is to randomize patients whose cancers have been identified to be linked to a mutation. And so far, only 2.5% of patients that have been screened have been included in the study, where they will be assigned to either a targeted therapy based on their mutation or a placebo. And there's now an increasing suspicion that this approach will help only a minority of patients with cancer. The last hype that I'm hoping to dispel is that personalized medicine will reduce healthcare costs. The reality of drug pricing is the smaller the target market for a particular drug, the more expensive the pharmaceutical companies are going to make the drug. So don't be fooled by them saying that things are going to get cheaper once we know exactly what particular gene we can target. Because chances are they're just going to be rack up the price. So the average annual cost of new targeted cancer drugs frequently exceeds $100,000 per year. So I think it's a bit of a myth that this era of precision medicine and era of genomics is miraculously going to make healthcare cheaper. 23andMe is a company in the United States, and what they do is they would completely sequence your gene, and then it would tell you your risk of developing certain diseases such as Alzheimer's disease or heart disease. What have we learned so far from the experiences of 23andMe? We know now that genomic risk markers, as I have mentioned earlier, do not seem to improve patient compliance with risk-avoiding behaviors. Just telling them that they're going to have, that they have a high risk of developing heart attack is not going to make them more active in their lifestyle, or it's not going to make them improve their dietary habits overnight. Worse, gene variant information has been shown to increase physician visits because the people start getting more anxious if they know that that they have a high risk of developing dementia 10 years from now. It increases the number of laboratory testing. They demand to get tested even more, and it also would increase patient anxiety. This is a company that was all pretty much at the center of a lot of enthusiasm. This is Theranos. So Theranos was a company that promised that with a drop of a blood, we will be able to measure anything from sodium to cholesterol to your blood count at a very low cost. And this made a lot of healthcare providers cringe because we were concerned that this will lead to a lot of over-testing and over-diagnosis. And this idea that patients and healthy people being repeatedly tested, it may sound revolutionary, and it may sound very, very sexy and promising, and it indeed attracted a lot of investments. But our main issue is that even if the tests were accurate, and we now know that they're not, when performed in massive scale and multiple times, overdiagnosis and overtreatment will increase as errors accumulate with multiple testing. So the idea here is you have to start thinking more broadly about what will happen to the big picture. And it's not just about attacking a very low-hanging fruit. That's typically what's being done by startup companies, but generally you have to have a very good understanding of the systems level issues that you're trying to address. Because even if you're able to address a low-hanging fruit, if there are other issues that affect the outcomes from that disease, then you won't be able to demonstrate any improved outcomes in the future. So this is John Unitas, and he reacted to Theranos as well as its downfall. So for people who do not know, Theranos is pretty much now out of the picture, because when they inspected the technology that they said that they had in terms of being able to measure everything from a single drop of blood, it turned out that the technology wasn't there in the first place. So what he said is that it's true that physicians use diagnostics less than optimally, but it is not clear that healthy people or patients can be trained to use diagnostics more wisely. And this is really someone who's very insightful in terms of looking at the innovations that's happening. Again, you have to always look at the broader picture. What will be the impact if indeed you're able to deliver what you are trying to, what you are promising to the public? So precision medicine on one hand versus public health. I'm not saying that precision medicine is bad. I'm just saying that precision medicine is very complicated, and again, one of my mission is to recruit more brilliant minds in terms of trying to operationalize this, who are very well aware of the limitations of precision medicine. So the very nature of precision medicine, which is targeted, specific, and personalized, inevitably produces interventions that are more expensive than historically successful preventive interventions that have been applied broadly to populations. So precision medicine presupposes that the individual is isolated from his or her social context, and that cellular data are sufficient to predict disease. And we know that that's not true. The human genome simply does not explain much of the variants of common diseases, and the variants it explains is rarely susceptible to direct medical or public health intervention. The question is, why are we here? And if you ask a lot of us, the reason why we're here is we're trying to improve the quality of care. I might skip some of these slides. I have like 3 minutes left. Trying to improve quality of care is difficult. The definition of quality is still, for the most part, very much influenced by whoever is trying to define quality. So at present, there are still no clear, universally agreed upon definition of healthcare quality, and multiple definitions exist from different organizations and really represent the value of that organization. In the United States, we have several groups that are rating hospitals, rating clinics in terms of the quality that they provide, and these are some of them. And what we found recently is that there's no agreement between those different groups. Like in one group, some hospitals are ranked very, very highly, and then in another group, they find that the quality of that hospital is actually poor. So there is still very much disagreement, really inconsistencies in how we define quality. And I'm going to go over 3 components of quality that I think we could agree with. The first is making sure that what we're providing is effective and is indeed improving patient outcomes. And that is not as simple as it sounds. So prospective randomized controlled trials have traditionally been looked at as the gold standard in terms of formulating these guidelines. But the problem, as we know about prospective randomized controlled trial, is that they provide an average effect, and this is the reason why personalized medicine became a big movement, and they evaluate one intervention at a time, and typically their inclusion and exclusion criteria limit their external validity. And we've also learned over time that there are so many errors and biases that surround these prospective randomized controlled trials. There have been some people who have been saying that most of what you read in the biomedical literature is not true. And this is concerning not just for the doctors, this is concerning not just for the academics, this is concerning for startup companies and industry, because you base your innovations based on the research that you read in the journals. And if you cannot trust them, then what are you supposed to base your innovations on? This is an editorial that accompanied a paper. It was penned by John Unitas. The title of the editorial is "How Many Contemporary Medical Practices?" So how many of the things that we do now are worse than doing nothing or doing less? And in that op-ed piece, to quote John Unitas, he said that half of what we know might be wrong and the other half useless. So that is very, very jarring for providers like me, and I hope it's also very unnerving for future patients like you. I'll skip this. And for that reason, measuring effective care is very limited to a few diagnoses and are very narrow in scope at present. So this area of quality improvement, I think, is still in its nascency in terms of really being able to transform the way we deliver healthcare. And the other element of quality that's important is this idea of service. So the patients being happy with what healthcare they receive from the providers. And at present, how do we evaluate this? In the United States, we evaluate this by giving patient surveys. Are you happy with the care that you got? Are you happy with the clinic? Are you happy with the hospital? So far, so good. That sounds so straightforward. And then there's a research that found that the patients who are happiest with the care that they're getting are more likely to die even after adjusting for how sick they are. They're more likely to incur more expenses. And this is the explanation behind that. The people who are happy because they're getting the antibiotics that they want, they're getting all the medications that they need, they're getting the CAT scans and the MRIs, even when the doctors did not think that they needed those tests in the first place. So this is very much dependent on their expectation of what to get. And that's the issue with trying to do these surveys in terms of measuring patient satisfaction. The last element of quality that hasn't really gotten a lot of attention is this idea that the doctors and the nurses and all the other allied professionals, they have to have a sense of teamwork and they have to have this culture of quality. This is something that is still very much in development. What we would like to do is to be able to measure the level of teamwork among the teams of providers who are providing your care. So this is not currently measured by hospital accreditation organizations, and most patients and providers are often oblivious to this element of quality. So one of the things that we're trying to work on is a digital quality system whereby we are constantly measuring the quality of care that's being given, and then it's providing actionable items at the point of care. So I'll skip this. I don't want people to leave this hackathon thinking that there are no success stories. There are actually a lot of success stories with digital healthcare. But for the sake of time, I won't be able to go through them. I have here 3 very good examples of success stories with health analytics and health informatics. I'm happy to share my slides with the rest of the group. And finally, this precision medicine, I talked about this yesterday who were present. Precision is not the same thing as certainty. And what you will find is that with the advent of precision medicine, we will present even more uncertainties as a result of more data that we have available for analysis. This is problematic because doctors are not trained to think in terms of probabilities and uncertainties. The way we were trained from medical school all the way to residency, we always thought it was about the correct answer, and the public has come to expect certainty from doctors. So assessing and acting on probabilities require new approaches to data presentation, risk quantification, and communication of uncertainty that we all struggle with. And that is where informaticians and other fields would be very helpful in terms of allowing us to grapple with more information and allowing us to deal with uncertainties. And we need to develop methods to help providers and patients absorb this complex information and make choices among increasingly numerous options with increasingly numerous trade-offs. So I'm going to end off with a slide that describes our group. We are indeed a very multidisciplinary team with data scientists and doctors working together. But my last slide is this cartoon. We like to bring together people from radically different fields and wait for the friction to produce heat, light, and magic. Sometimes it takes a while. This actually shows how difficult it is to bring a multidisciplinary team. It sounds very simple and straightforward, but just putting a clinician there and an IT developer and an epidemiologist, would not suddenly miraculously improve the innovations that you're trying to deliver. Thank you. Or we could maybe proceed with the next.